Okay, so just wanted you guys to take a look at what I chose to do for my student my student project for this year in Physics 2. I decided to make a cable antenna so I can get, in a sense, free cable for when I go to college, because I'm going to be going to Alabama next year, and so I don't think cable is very cheap over there. So, and I kind of had an interest in something kind of related, physics related, in TVs, because even though we've gone through many of um, different projects, like when we did the paper airplanes, that was kind of the physics behind flying, and then the cars. So I just wanted something a little bit different, and definitely the cable was one of the different ones. So, all right. So to kind of look at how the physics concept behind it works, so for an antenna to work, an antenna theoretically needs to get waves or receive waves from, say, a satellite that is projected from TV station sent through, and it will take these waves that it receives, and it becomes, or this in this case, acts as a dipole, and so as the waves continuously pass over through this copper rod, the dipole, which is positively charged atoms and negatively charged, they just keep passing through each other, passing through. And um, in a sense, for how I built mine, these these waves will send basically all the positively charged over here, and all the negatively charged ones over here, and they keep passing through. And so in order to get that actually onto the TV, we have to connect it through a coaxial cable. And so all these different pulses back and forth, it sends an electromagnetic pulse through, and which is therefore reconfigured through this coaxial cable that then plugs in the TV through this. That also has a copper wire going through the middle. And so that's kind of the sense of how it works, physically speaking. You'll also see in the video of what I'm about to show you of it actually working, to where in order for the cable to actually receive and to transmit those signals sent from a satellite, it, it has to be stationary, and so that's why I actually have the tape on it, and you'll be able to see in the video, so that stays steady. But kind of to show proof that that it was actually working, like fully plugged into the TV, it was completely connected, wrapped around with the copper wire in order to make sure that it received that signal. And so if you therefore mess with the electromagnetic field by moving around the actual antenna, it makes the signals that it received pretty choppy, and you'll see on the TV as it kind of stutters and gets a bad connection when you move it, and then it comes back to be a good signal when you stop it. Alright, so this video here is just to show that it was connected to the TV, and that the coaxial cable was connected to the actual antenna and receiving signals. And that video was kind of just to show you the actual functionality of the antenna. But so here is a concept I tried to follow at my first attempt, but then realized pretty quickly that it wouldn't quite work with just a plastic hanger and two cans. And kind of the issue is I don't have a picture of it because I threw it right away. I threw it away right when I tried. And then here's an actual picture of the final product that I built based off some of the research I did and some of the simpler concepts that I found that would work the best. And it was just comprised of a already used pill bottle, a cut up copper hanger, and then just a couple pieces of tape to try to hold it down, and coaxial cord. So kept the cheapness pretty well. To kind of wrap it up here on the concepts, I just wanted to add that for when I actually go to college, and if I were to follow through on the idea of having the kind of reduced price TV antenna or cable antenna, I was actually thinking of building something more along this concept. It's a little bit more complex, but based on kind of the research I did. This is more like a traditional Yagi-Uda antenna, which definitely will bring in many more channels and better signals for me. So if I continue to actually follow through with it, it definitely will look something more like this. So I hate to say, kind of for my project, it made it a little bit harder to get a quantitative analysis, but as for kind of data, it picked up 14 different channels, and it took about 3 minutes to get pick up all those signals. And I would say, in a general sense, that it kept pretty much every channel clear and didn't really have any stutters in the connection, other than when I was just moving it just to show that it was working. So yeah, that's kind of it for my student choice project, and I'm very glad and I got to learn something new about TV antennas.